Welcome to Study Loop.
Hello students, in this question there is a person standing on top of a building. That is, this height is 3.5 meters, and he is throwing a basketball onto a billboard which is rotating. So this is rotating, that means it is rotating at a height, rotating billboard with a radius of, this is a rotational motion. So the height is being changed. So there is a fixed height, let's call this f, and then there is the change in height. So this billboard will be rotating at a radius of 3 meters. So we need to know if it hits or not. That is the point here. So this rotation creates a chance for hitting or not hitting. So the height of the billboard will be equal to, this is the height h, some fixed, the fixed value plus r sine uh, whatever the angle is, or you can say omega t. So we are not given the omega value. So this will be the omega will be the angular frequency and t is the time period. So that will be the case. Now he will be throwing. So governing by the equation of motion s is equal to s0 plus ut plus half at square. So we have a velocity, and we can use v is equal to u plus at as well. So we have the initial velocity u0, which is given as 22.9 meter per second, and the distance that is s, which is equal to 32 meters, and the height h is given as 3.5 meters, and r is equal to 3 meters. So these are all the given equations. So when he throws this ball, so the maximum speed and the minimum speed of the ball is given as, that is v, and the maximum speed of the ball will be the initial speed, then it will go to 0. So u ratio between the maximum, which is u by v, is equal to 1.7. So u is equal to this is u0. So v will be equal to u, which is 22.9 divided by 1.7. So that is equal to 13.47 meter per second. So that is something that we got. So we got v, we got u. So we can find out, we know the value of g, so we can find out t. So t will be equal to v, which is 13.47, minus u, which is equal to 22.9, by g. A is g here, acceleration due to gravity, or we can say, or whatever the acceleration is. So instead we can just make this in the y-axis. So u in the y-axis will be equal to u sine theta. So sine omega t. So 13.47 sine omega t minus 22.9 cos. This is the again the final velocity that also has the sine component, sine omega t, will be divided by t will be, this will be g. So this will be g in the y-axis. So that will be the case. So we can say this is 9.81. So you'll get time period will be equal to 0.96 seconds with a minus sign. So two times that will be the case. So the trajectory has symmetry. So there is two times that minimum to maximum. So that will be equal to 1.92 seconds. That is the trajectory time period. So once we got the time period, we can now with sine omega t is there. Sine omega t is there. So that is the time period of oscillation, that trajectory. Now coming to know if it hits or not, we are not certain about the value of omega t. So the displacement in the x-axis, sx, will be equal to 32 meters. That will be equal to the initial velocity, right? Whatever the initial velocity is. So that is 22.9 times sine 22.9 times cos omega t, plus that is initial velocity, times t times t, and there is no acceleration in this case. So this is the whole distance that is traveled. So that will be equal to 22.9 times 1.92 times sine omega t cos omega t. That will be the total distance traveled, which is equal to 32 meters. Right. So we can find out this omega t component. For that, we can go in another direction. We are given this ratio of 1.7. So that will be the tan theta value. That is the ratio of maximum to minimum. So tan theta is equal to 1.7. So theta will be equal to tan inverse 1.7. That is equal to 59 degrees. So we got the theta value. Now we can substitute that. This is sine theta cos theta, right? So we can say that we have t value. So this is also 1.9. So time period will become 1.92 times sine 59. 1.92 times t will be equal to 1.92 times sine 59. So that will be equal to 1.62 seconds. So we got the time period. Now coming to this case, this rotation, this is rotating at 1 r times sine omega t. So let's assume that this at a time when t, the time period is matching with this situation, right, at a fraction of a time. So we don't know the omega of rotation, which is not given. Let's assume that some omega is there. So we can go back here and we can write down height of the b is equal to some fixed value, which is equal to, which is not given as per the question. So some fixed value plus radius, which is 3 times sine omega times 1.62 seconds. So that is the timeline, right? So height will be equal to 4.88 times, not that, but this is the case, this is the equation, and this has to match, right? The maximum, let's assume that the maximum it can have is 3 meters. So 1.5 meters it can get to closer. So that will be 32 minus 1.5. So 32 minus 1.5 will be the case. 32 minus 1.5. So that is equal to 30.5 meters. That is the distance. Now, if that's the case, then if it hits or not, without the information of omega, or we cannot go through that calculation, but we can estimate that with an angle of theta, right? Theta is equal to 60 degrees, and the position it being of 30.5 meters, it can hit 60 degrees approximately, that is 59 degrees, 59.8 degrees. Then only it can hit. So this is a solution. I hope you find the solution useful. Thank you.